Hey geometry students, today we are going to talk about volume and density. What we're really discussing here is what it means to be light and heavy, okay? And that'll help us prepare for later activities that explore density. Some of you are already taking chemistry, and some of you have explored density in your science classes otherwise. So first, let's look at these pictures. Which has more mass, 1,000 kilograms of feathers or 1,000 kilograms of steel? Explain your reasoning. What I'd like to discuss here is what does mass mean? It may be helpful to discuss how mass is measured. That way we can conclude by definition that both of them have the same mass. Okay, so we actually measure mass, on a scale. Oh, I certainly can't draw a scale. I mean, I'm picturing my kitchen scale, which, is a big rectangle with a display on it, with little feet. And if I put all those feathers on there and it weighed out to, 1,000 kilograms, but I can't measure on my kitchen scale, right? Or if I put the steel on there and it measured to 1,000 kilograms, then they're actually equal, okay? So here, these have the same mass. Okay, to rewind, mass is measured, when you weigh something. So 1,000 kilograms of feathers has the same mass as 1,000 kilograms of steel. Now, they won't have the same volume. 1,000 kilograms of feathers are going to take up a lot of space, where 1,000 kilograms of steel will be a smaller amount of space because it's a denser material. Okay, so we can talk about the space the substance might occupy. All right, we do know, we'll go over this again, that the definition of density is actually mass over volume. Okay, where the feathers take up a lot more space, so the volume would be bigger, even though the mass is equal, where the steel is going to take up less space, even though it has the same mass, so it's going to be much more dense. I don't know why I put in another slide here. I'm sorry. I'm going to use it to my advantage. We say density is mass over volume. So I could actually say I have a metal object that weighs 150 kilograms and takes up 1,000 cubic centimeters. And if I divided that, I actually get 0.15 kilograms per centimeters cubed. Okay, that would be my density. So each cubic centimeter, I don't know why I drew it like that. If that was 1 cubic centimeter, it would weigh 0.15 kilograms, sorry. So that's 1 cubic centimeter. That would weigh 0.15 kilograms. Okay, that's our density. All right, 17.2, light as a feather. So here we're going to use the concept of volume and unit conversion to really work on our understanding of density, okay? If I read, the feathers in a pillow have a total mass of 59 grams. The pillow is in the shape of a rectangular prism. That sounds very uncomfortable, right? Okay, that is my pillow. And that measures length by width times height, 51 by 66 by 7. A steel anchor is shaped like a square pyramid. So we have a square, and okay, I can never draw square pyramids. I should try a little bit harder. Let's try. Maybe if we made this a little funky, and then we went up. Nope, that last. Close. Each side of the base measures 20 centimeters, and then its height is 28 centimeters, and the anchor's mass is 30 kilograms. So what is the density of the feathers in kilograms per cubic meter? So density is mass per volume, but note my units. This is 59 grams. If I change that into kilograms, I have 59 grams. 1,000 grams is 1 kilogram. So 59, I move that decimal over 3. I have 0.059 kilograms. And then volume, I need it in cubic meters. So let me change pen colors so we can track it. This would be 0.51 meters, 0.66 meters, and 0.07 meters. Where I take, how did I do that? You should ask. Miss Carly, how did you do that? I know I have 100 centimeters is in 1 meter. So I just take 51 and I divide by 100. And that gives me 0.51. So I'm going to multiply my volume, 0.51, times 0.66 times 0.07. So I have 0.059, which is my mass, and divide by my volume. 0.51 times 0.66 times 0.07. And that gives me 2.5 kilograms per meter cubed. Okay, that was way harder because they made us change our units, kilograms and cubic meters. So that's the feathers. Now how about the steel? Okay, that's a square pyramid. Everything's in, all the stuff they give us is in centimeters, except the anchor's mass is already in kilograms. And we want kilograms per cubic meter. So mass per volume, I have 30 kilograms. And if I change those measurements, I'd have 0.20 meters, 0.28 meters. So the volume equation for a square pyramid is 1/3 big B, which is 0.2 times 0.2, because that's the square, in meters. That'd be 0.20 meters, 0.20 meters, and 0.28 meters. So 1/3 big B, which is 0.2 times 0.2, times H, which is 0.28. So that gives me 30 over 0.2 times 0.2 times 0.28 times 1/3, 0.0037. 30 divided by that answer is 8,035.7 kilograms per meters cubed. Which is a way bigger number than the feathers, which it should be because it's an anchor made of steel, right? All right, I need another page. All right, we already did number 1. Sorry, forgot to turn on my pen. We already did number 1 and number 2. Now, what is the volume of 1,000 kilograms of feathers in cubic meters? Well, amazingly enough, once we know the density, that density is a ratio that holds true for all feathers, okay? I can use that to calculate other things. So if my feathers were 2.5 kilograms per meters cubed, and density equals mass over volume, I can figure out the volume of a certain mass of feathers. So I can plug in 1,000 kilograms over volume, because that's my formula for density, and solve for V. So if I multiply both, so there's my equation. I can take that and multiply both sides by volume, by the variable volume. Cancels out over there. I've got 1,000 on the left and 2.5 times V on the right. Divide both sides by 2.5. And I get volume equals 400. Now my units will be, let's see, this was kilograms, this was kilograms per meters cubed. So my kilograms cancel out, my meters cubed goes to the top. The volume is 400 meters cubed. I just solved for the unknown in my equation. I can actually take this and rearrange it. D equals M over V by multiplying both sides by V and saying mass equals volume times density, which is what I did. Nope, I didn't. I wanted volume. Sorry, rewind. And then I divided both sides by density and got volume equals mass over density. Okay, that's what I used right here. Cool. Let's try number 4. All right, number 4 says, what is the volume of 1,000 kilograms of steel in cubic meters? Well, we know that the density of steel, I don't know why I'm still writing in red, sorry. The density of steel was 8,035 kilograms per meters cubed. And density is mass over volume. And we're looking for volume, which is right there. So let's plug in what else we know. I know that 1,000 kilograms of steel over the unknown volume has a density of 8,035 kilograms per meters cubed. I said it once, but I'll say it again. That density value, that holds for all steel, no matter what, okay? So that's why I can use it to find the volume of 1,000 kilograms. I can use that density value. Okay, so let's, again, I need to take this equation and solve for volume. Multiply both sides by V. I have 1,000 kilograms equals 8035 kilograms per meters cubed times V. Divide both sides. Kilograms per meters cubed. Kilograms per meters cubed. Those cancel out. My kilograms cancel out. I'm left with meters cubed on the top. Do some division. I get an answer of 0.124 meters cubed. So you would think here we're comparing the exact same mass of both, where the volume we have for the feathers was 400 for that mass because it's not as dense. It's big and fluffy. And then the volume for the steel should be much, much smaller, okay, because it's compact and heavy. A fishy situation. An aquarium manager drew a blueprint for a cylindrical fish tank. The tank has a vertical tube in the middle in which visitors can stand and view the fish. The best average density for the species of fish that will go into the tank is 16 fish per 100 gallons of water. That provides enough room for the fish to swim while making sure there are plenty of fish for people to see. The aquarium has 275 fish available to put in the tank. Is this the right number of fish for the tank? If not, how many fish should be added or removed? Here we're really doing density again. Okay, the density of this is going to be 16 fish per 100 gallons, which I'm going to convert into a number. Just like the density of the steel and the feathers was kilograms per meters cubed. Okay, this right here gives me 0.16 fish per gallon. Okay, 0.16, I know we can't have 0.16, right? That's not possible. But I know that I have a tank. Let's see. I have a tank with a certain given volume, which we need to calculate, right? Okay, I need a new piece of paper. So I have 0.16 fish per gallon. I need to figure out the volume of my tank. It's a cylinder, so big B times H, but I need to subtract the cutout in the middle. So if I do that radius, that's going to be 2 plus 3. So pi 5 squared times 4 minus, so that's the outer cylinder. Now the inner cylinder is just 2 feet. So I'm going to subtract pi 2 squared times 4. So 5 squared is 25. Times 4. That gives me 25 times 4 is 100 pi. And 2 squared is 4 times 4 is 16 pi. So 100 pi minus 16 pi gives me a volume of the fish tank of 84 pi. I need this real number, so 84 times pi. That gives me 263.9 feet cubed. So that is the volume of my fish tank, right? Now something that they didn't tell you that you really need to know is water. Okay, I need to be able to change that feet cubed into gallons. So I happen to know, and if we were in the classroom I would have told you this, that 7.48 gallons per cubic foot is the conversion factor for water. So if I take that value, 263.9 feet cubed, and I multiply that by 7.48 gallons per feet cubed, I get, let's see, is that still in there? Grab that in my calculator. Times 7.48, 1,973.9 gallons of water. Okay, now we know that that's our goal is 0.16 fish per gallon. Okay, so if I take that 1,973.9 gallons, 1,973.9 gallons, and I multiply that by 0.16 fish per gallon, I get, let's see, oh, sorry, I multiplied it by 0.18 by accident. 315.8. I can't have 0.8 fish, I know. But I need about 316 fish. That's what I need. So they've only have 275 fish available. They need more, okay? So they need about 41 more fish to have the right fish viewing capacity so that the patrons are happy. Okay, that was a tough problem. I think you guys, if we were live together in the classroom, would have been just great on this part and absolutely excellent on this part. Okay, you didn't know this part, which kind of stinks, and we would have worked through this part together. Okay, so that's all right. Okay, we're doing the best we can right now, and I'm so impressed with you guys, with your hard work. So that's it for today. Good job.